clean the surface of the platinum. Make sure the platinum's clean. No. Starts going.
Oh, yeah. Were you here for that strategy on the board? Or did you do the actual?
Oh, what an ants. Sitting in front of me.
Right.
You just take the volume and the time to go out.
That's not doesn't film too well.
This is for.
Shut this row of lights for me.
Did you get the chart right?
Pay close attention because it's going to start to go. I should it should have glowed first.
I saw it a little bit.
See if we can get it to blow up again.
There it goes.
Okay.
So you got 0.035. Oh, you got 0.034, right?
It's going to get louder now. Just don't get scared.
Oh.
Explain, Gorlick.
The vapors are reacting with the outside of the platinum.
Incorrect.
The oxygen that we're burning the methanol, so then there's oxygen in there, so it comes in contact with the platinum because the platinum acts like a catalyst. So they're actually
Did I not
reacting.
say that? I said
Because
that.
it's
But
platinum
she said the
catalyst.
platinum is reacting. Is that true?
No, because it's being used, but it's not being used up entirely.
It's
Yeah,
actually
the
it's
outside
a
of the
surface
plat-
science right now. It's the outside of the platinum.
It's a catalyst, so it's not used up in it.
Correct. And what it's doing, it's grabbing the molecules and they're combining and connecting to the surface of the platinum. And when you get the right ratio, you get the explosion. But it's happening at the temperature in there, which is not real technically the activation energy it needs. It should be insufficient, but because the catalyst is there, it changes the path, the mechanism steps, so that you can do the explosion at a much lower activation energy. So when it explodes, the hot gases rise through the front. While the hot gases rise through the front, they're bringing the cool gases from behind. And that's what the divider's for. So now when the cool gases come in, the oxygen comes in. And when you get the right ratio, it blows up.
The longer it stays in there, is it the faster between the little...
Yeah, well, what's happening, the heat of the reaction is providing more activation energy. So it's going to react faster. And it should continue to blow and explode as long as the methanol vapor keeps going out. What happens, that's what the pad on the table is for. So it doesn't cool. Because if it cools, then the vapor pressure will go down, the amount of vapor will go down, and it's harder to get to the right ratio of oxygen to methanol. Cool trick, right?
So the platinum like orients it
Yep.
correctly.
The platinum aligns the molecules up correctly so that when they're going to use the activation to break their bonds, it takes less energy. So it's, the catalyst creates more effective collisions. That's what it does. But it also alters the mechanisms. What you're going to learn tomorrow is the mechanism steps, chemical reactions. And what happens, because the platinum's there, it doesn't use the same mechanisms. It uses a different mechanism, which doesn't need as much activation energy. So that's why it's able to explode or combust.